Hello, everyone, and welcome to another episode of Satisfying Software. Today, I have with me Thomas Coopman, who is a consultant at Aardling and my best colleague, and also the creator of the DDD in Language course that we have on DDD Academy. Welcome, Thomas.
Hi, Yin. How are you doing?
I'm good. How are you?
I'm fine, thanks.
Yeah. So, Thomas, I heard that you know a lot of programming languages. It's something I've always been impressed with. So, how many do you actually know?
Ah, you should have asked me up front so I could have counted. I think it depends on what you define as knowing. I written in I think at least 15 programming languages. I've written more than, let's say, uh, some lines of code. So I've used quite a lot, and I think I probably used close to 10 in production.
Wow,
So
that's
if
a
that,
lot.
well, if that counts as a lot, then that's a lot. Yeah.
Most programmers know like one language. I always felt I was like very good with being fluent in four. But you go with 10 in production. So I would say that's a lot. So which one is your favorite of all the 15 ones you actually know?
I just want to my career is going for a while now, so I'm not fluent in all of those anymore. And my favorite is, I would say, is more yeah, it depends on the when and what and so on. I would say if I had to pick a language to build something in and I had full control over most of the things, then I would probably pick Elixir. Um, I really like the language, so it's not just that um, that it's the best for building stuff, but I also really like it. Um, so that would probably be my choice. Now, when we would, if you have to work together with others and they don't know the language or they don't like other programming languages that are not that mainstream, I might need to pick something else. But that would be my first choice. And if it's something that I'm not like it's it is production ready. You can use it in production, but my knowledge is a little bit more limited. Then my favorite language in that sense is Gleam, and I'm wearing a uh, a sweater here of the language. That's the most fun one. It also runs on the Beam virtual machine like Elixir and Erlang, but it's a statically typed functional language. Elixir is also a functional language, but it's not statically typed yet. They are working on it.
All right. So as I said, you created the course DDD in Language for academy, and so that teaches people how to implement tactical patterns in code. So if we look at programming language from that perspective, which language would you recommend, or does it not make a difference at all?
I for that perspective, I probably would. I don't mind that much. I don't think there are a lot of languages where, well, there are definitely stuff that there is a lot of stuff that matters, but I wouldn't pick a specific language because of a reason of tactical patterns. That wouldn't be my reason to choose some language over another.
Okay. So you mentioned Gleam. It's a functional programming language. I feel that most of the focus in the past, I think, 20 years now since the book came out, has been object oriented. Um, like, how is writing in a functional program when it comes to the tactical patterns? How is it different?
Uh, I'd say not that much, but on the other hand, it is quite different. But probably that is something that we're going to get to in the conversation. But for me, if we're talking tactical domain-driven design, so let's remove patterns there and just talk about tactical domain-driven design, it's all, for me, it's all about expressing a good model in code.
Mhm.
And the tactical patterns are a way of supporting that. But the first thing and the most important thing when you're doing domain-driven design is expressing your model in a good way in code. And I think both object-oriented languages and functional languages are able to do that. And maybe higher level languages that allow more expressiveness have a little bit ahead about maybe the lower level languages, because it might be easier to just purely translate your model into something that's not necessarily readable for everyone, but that you can identify the model more easily in without being stuck in technical programming things.
Yeah. I remember like C# and F# has been the languages for most of my career. And so I programmed in F# for 8 years. And I remember that way back when I swapped from C# to F#, that immutability I had was like God's gift. It was like this amazing thing that I did not have to care about all of a sudden, especially when it came to value objects, because back then, and C# has changed a lot since, and now you can sort of have that easily as well. But having immutability into C# was not simple.
Yeah.
It was hard.
Yeah, that's indeed maybe one of the things that I would recommend in picking, like in general, in picking a language, if you have that choice, because the reality is, of course, that often you don't have the choice and you need to pick whatever's available. But immutability, if you have first-class immutability support in your language, yeah, that is going to help you a lot. And maybe we can add another one. And hey, because you were saying, hey, which language would you pick? Of course, in our course, we do have a bit of a bias. Well, one towards languages we know we can teach well, of course, but also um, we do pick languages that where tactical patterns have more impact, and languages without types. For example, in my opinion, you can still do tactical patterns, but the advantages that you will gain from it are lower because you don't have types to protect you from certain kinds of things. So you don't have types as documentation to support certain kinds of things. You have to do more effort in the language to implement those patterns well. So you get to different kind of trade-offs.
Yeah. You're talking about languages like Python and Ruby here.
Well, not Python anymore, because Python has decent typing support. It's not like, I'm not looking for perfectly typed languages. For example, Elixir doesn't have types, but it has really good pattern matching, where you can express in pattern matching and what you're expecting. You kind of can look at, for people who are not familiar with it, you can kind of look at it like runtime type checking. It's a bad analogy as soon as you dive deeper, but it's it's good enough for this conversation, I guess. And Ruby, I know there are I haven't looked at the Ruby landscape for a while now, but I know they have been doing things there as well, but that might be an example. Another one is JavaScript. We pick TypeScript over JavaScript because, well, expressing, for example, having a value object, using value objects, let's say the typical ones that we use in examples are things like money. You don't have anything at all in the language that shows you or helps you saying, I only expect money and I will return a money thing. And then suddenly you lose some of the advantages of expressing stuff as value objects.
That's something I felt with F sharp because types were so cheap. I actually could express a hell of a lot more. Like one of the things I started doing was saying that so you had some sort of you needed to validate some things, making sure that whatever you got was actually valid before you started executing a function that worked on your type. And then so my function accepted a validated customer or a validated money, for example. And that showed people that, okay, well, you actually need to validate this first because else I am not going to check this. And also that functionality and those constraints, there's somewhere else completely. Make sure that you have done that. So I felt that because, those types were so cheap, I could be a lot more expressive with F sharp than I could be with C sharp because you had to make a class, you had to this, you had to that. Like it was a lot of work back then. That's 10 years ago. Yeah.
No. But I get what you're saying. The overhead of adding new value objects in a language like F sharp is really, really low, and it's higher in C sharp. It's improved if you are willing to be a little pragmatic about some things. Yeah, they now have records, but records aren't perfect value objects. But for me, they're good enough often. That's definitely true. If you need to write 30 lines of code to simply define a new value object that's almost doing nothing but represents, hey, this is a validated thing. Yeah, you're probably not going to do it all the time. And like you're saying, in F sharp and quite a lot of other languages, that's nowadays really cheap. So you will try to be as expressive as possible. Yeah. For me, that is something though that in the course people often ask those kinds of questions. And for me, I personally don't recommend that people purely look at the tactical patterns. They need to look at tactical patterns in their current context, and their current context adds their programming language and whatever kind of style that they're programming in. So if the overhead, for example, for all kinds of different value objects is too big, well, then you need to find the right balance, which works for you. You have to find a balance so that you keep doing it. That it's not, we did this for a couple of weeks, but was too much work and we completely abandoned it. And no, you have to find the balance that works for you and think, of course, about what kind of trade-offs you have. Okay, if we reduce the amount of value objects, or we, another example, you now made the validated versus non-validated. A value object can be nested. In F sharp, you're probably going to go for something that's deeply nested until the point that the lowest level of value objects just wrap one primitive.
Mm-hmm.
If the cost of creating value objects are higher, you're probably going to have more coarse-grained value objects that that encapsulate lots of primitives. And then, you build what works for your language, but think about what the trade-offs are there.
Yeah. So when do you know you're going, you said be pragmatic and also you're in context, so check out how easy it is with your programming language. When do you know you've gone too far? Have you ever gone too far yourself?
Probably.
But not your problem anymore.
Yeah. The problem with, like, you can go too far in both directions. You can go too far and we're over modeling stuff. And I probably a symptom of that is that you're constantly changing between types and all of that. And then under modeling might be where the things are too generic and that you don't really express the model really well, that you just have some generic model. I probably, I will definitely have over and under modeled stuff. I don't think it's necessarily an issue as long as you detect it. And if you detect it, you're willing to refactor. It's you can't perfectly model your or you can't perfectly design your system from the beginning. You have to build something. You have to build something working, hopefully first. You want to put that in front of customers, get feedback, and then you're getting into a cycle where you iterate, where things are going to change, and then you're going to feel, I need to add this new feature, but my current code is working against me or it's working for me. And then you can start refactoring. Personally, I've been, and a lot of things I've done, I've been in the lucky situation that we had room for refactoring, that we could always, like for me, refactoring is part of writing code. It's non-negotiable. But we're consulting at quite a lot of places here, and you and we've both noticed that in some places, or in quite a lot of places, they write something once and then they move on to something else and they never get back to that. And then it's the problem with a situation like that is that it's more important to do it right from the first time. And it's really hard to do things right from the first time. Because you need to learn so many things.
Yeah, I know. I wasn't laughing with your
Yeah.
statement. I was remembering all the times all the
Yeah.
first times I got wrong, Thomas.
Yeah, yeah.
So thanks for
Uh,
that.
it's all like I've never written something that I looked at a bit later and thought, I could probably improve this and this and this. Yeah, and I think that's normal, and it's something we should work toward continuously improving.
Yeah, I often feel that the feedback loops are missing. If I go to customers and I look at it, the feedback loops are missing, like validating, is this actually working the way we want it to work? And even if the feedback loops are there are no triggers to say, should we reconsider our current domain model and see if we can come up with something better? Because I feel it is difficult. It's an instinct I have, right? Sometimes you look at a feature and you're like, okay, we can actually put that in the model we have. We add a few properties to a few entities and things will work out fine. At some point, you're going too far. And I think noticing that it's one of the most difficult skills, I think, as a programmer.
Yeah, but and it is really difficult, and I think, well, it's difficult, but it's also not that difficult. I think the issue often is programmers wear one hat. I need to produce code.
Huh?
And as soon as you wear another hat and say, hey, now I'm going to review and think about what I'm doing, it's a lot easier to detect those kinds of things. It's still hard to make a decision, because it's not because you detect something that something's wrong that you can make a decision towards something better. That is still very difficult, but it will help you detect those situations. But yeah, programmers, developers, whole teams often just have the hat on, I need to produce features. And they don't reflect on, like, hey, if we improve certain things here, we'll be able to deliver features better and faster. And they just keep going, which is definitely an issue.
Yeah, I think it's more of that's what we were taught. Like from when I finished my bachelor, like that's what you were taught, right? A programmer produces code and that is what you're supposed to do. And then you go into the field, and you're like, well, I don't know how my users are using this. I have no idea, what am I doing? Is this okay? And then you're like, For me, that's how I discovered domain-driven design in the first place. Like, there has to be a better way to do it than just sit down and produce code all day.
Yeah. The funny thing is actually, if you're explaining domain-driven design to someone who doesn't know development, and you're saying, hey, we're listening to what the business wants, and we translate that in quality software, and we check that that's actually what it's doing, everyone says, well, that totally makes sense. Hey, that's obvious. Isn't everyone doing that? And but the reality is often no, not everyone is doing this. Hey, and a lot like you're saying, hey, produce code, and we've been taught that. Yeah, one of the issues, of course, is that a lot of or that teams or are often only involved as soon as a solution has been defined, and they don't even, yeah, they were not involved there to understand the problem and to define a solution themselves or to help with defining the solution. So yeah, then it's hard to expect them also to look at what are our users doing, how are the users using it, are they happy with this? Yeah, all of that is hard in that sense.
Yeah, it is. I think the reason I never had that as a programmer is before I studied programming, I studied to become a teacher in Dutch history and informatics. So it was always about computers. But those are topics that, if you go for the general sort of education, that's fine. But if you go to those who actually learn a profession, where I ended up doing my internships, they don't really care about any of the subjects I was teaching. And my mentors then, when I was doing it, say like first day of school, what I do is for all my classes, I go into their workshops that they have here and I look at what they find actually interesting. And I see, so I am in, and he was explaining all of that. And I think I sort of took that with me when I started programming. Like, I'm doing this for someone. I hope to help them as I hope to help to teach the kids. I'm going to go around and see what they're doing and what is important for them and how I can help them actually achieve that. I always think that my attitude came from there. How
Okay.
did you sort of learn to look further than coding?
That's a good question. I haven't that's something I haven't reflected on in the past. I am like right now, I think so I started development as a hobby when before like I think 14, 15 years old. So at that time, yeah, it was building things for myself. I always put a lot of time in it, and then I got to a point where it sort of worked, and then I lost interest and did something else. But the advantage, of course, of building something for yourself is that you are trying to solve a specific problem. But I guess the main thing is when I yeah my the first job my first job was not really pure development job, was more project manage. I was doing lots of things, and I came into contact with my users from the get-go. And like the really first thing that I was doing was I was project manager. There was a consultant company developing something for another party, and I was in the middle. Um, and so I needed to make sure that that consultant company was doing the right kind of stuff. And I was looking at what they're doing. I was from the beginning, I was whatever they're promised here, that can't work. And I started to talk with people. And I guess that's also um, yeah the way I started doing that. I find it sometimes I find it I find it kind of weird that it's not the default. Like, you're building software for a reason, and the reason is that people are going to use it, for example, and they should be happy with it. So check that those people are actually using it and that they're actually happy with it. It's not that strange. I don't think it's strange, but apparently, um, in a lot of situations, people are happy with just building something and putting it in production and doing the next thing. I did notice, because when I was coaching or consulting, that if you get in a situation like that where people are building something, pushing it pushing it in production, and then moving on to something else, the satisfaction of those teams often was lower then when I started then coaching them and saying, okay, let's have feedback loops, all of those things, often they ended up with higher satisfaction. Even though in the beginning they were like they were not really bought, but then we knew we need to talk with some customers, and that's extra effort and it's extra work. But in the long term, it's from personal experience, so not anything scientific, but from my personal experience, that those teams often ended with high satisfaction because they were building stuff and they knew they were used and they were talking to people. And sometimes it's a little bit of a burden when they come back to you and said, oh, that's not what I wanted. But when they say, hey, I'm really happy with this, or look, this is how I'm using it. Yeah, I've not met a lot of developers who weren't satisfied by something like that.
Yeah, it's so I said, hey, we're talking to the users and we're helping them. One of the difficulties I also have seen is then we have all this information. We may even done it through collaborative modeling, and we have an event storm of a domain story, or anything like that. And then what? Now I have to we have these tactical patterns, and I have to get from A to B somehow. So how do you start with that?
We have a video series on it. um,
We do.
uh, um, like the goal of the collaborative modeling, the event storming, is to first of all make sure we understand the problem, and then secondly is like agreeing on, okay, what are we going to do, or where, like, define something where you say, hey, if we could do this in 3 weeks and 4 weeks, that would be great. So I'd probably start with that, and then my question becomes more of, okay, do we feel like we know enough to start coding, or do we need to define the model better? And then it's very iteratively. I might start with doing some event storming modeling and then jump into some coding. People indeed ask often, hey, how do I translate my event storm into coding? Um, I don't really do that. I use my event storm as a guideline, but then I go into coding with all the knowledge and I code in a way that makes most sense in this context. Hey, I've seen people, I have a command in my event storm. That means I need to have a command in code. That doesn't, that's not necessary. A command can just be a function call somewhere on an object, and that's good enough. So then I iterate a lot between the two things. Like I do some coding. Is it still going forward in the right direction? I validate, and then I might go back to my event storming. Um, Yeah, it's something though that we should probably figure out better ways of teaching still. One approach that I've experimented a little bit with in the past is by creating some kind, like, when you have your event storm, you basically have a scenario. And by then writing somewhat procedural a scenario test. Hey, okay, we have this first command. Let's write a test that does this. Let's write some code that we can move forward. We're expecting, I'm not calling, at that point, I don't call them events yet because, well, if we were building an event source or a message based with system, then I would probably call them events. But if we didn't make that decision yet, or we're not in that situation, I would just call them, we decided something, something happened, it was a decision. And I would write my scenario test just based on the event storm and write just enough code to make that working. It all goes like I'm just like touching the domain layer. I'm not worried about API services, whatever. Purely touching the domain layer, and I write my scenario. Not top down, but from the left to the right until I'm there. And I'm not going to have. I probably will not have created a lot of value objects yet, and not a lot of domain objects. But when I'm through that first scenario, I will already identify, this doesn't feel good. We should refactor a little bit. This doesn't feel good. And then you can start refactoring towards other tactical patterns. And maybe when you're happy with that, you can add another scenario and continue from that. It's something I experimented with. It worked quite well. But I haven't done enough experimentation to say, hey, this is a good path for everything. And it probably isn't.
Yeah. Okay. So we're almost at the end of the episode. So that brings us back to our second to last section, and it is called Rant Away, which I want to give you a few moments to be able to talk a bit about, criticism on the tactical patterns, things you have noticed, things you think should change, or we're not dealing with it all that well. Does anything come to mind?
Yeah, I think that last sentence, things that we're not dealing with well enough. There is a lot of content on the web on tactical patterns, and too much of it is, this is the way you should do it. And a lot in too many places where I've gone, people thought, hey, but I read it and it said it should be done like this. And we tried it, but it didn't really work for our situation. Like, yeah, you in workshops, I often say there is no DDD police. No one is going to tell you, no, this is not the right way, or I hope not that people from the community are not doing that. Hey, of course, we want to educate you, but you do not have to use all the things the way they're prescribed. You have to understand their properties. Why is immutability in a value object important? Why do we want a value object to always have a correct state, or an entity to always have correct state? Understand those properties first. And if you understand those properties well, you can start making other trade-offs. You can start changing from the prescribed way into something that works for you. So you do not have to blindly follow the patterns. It's more important to understand why we have those patterns, what their properties are, and then adapt them for your situation. So that would be probably my main thing if I'm thinking about what as DDD community we could probably do better.
Mm-hmm.
Is trying to explain that trade-offs are allowed, that you don't have to blindly follow things. And I see too much content probably out there, and of course it's hard because if you're writing a blog or whatever, being nuanced is not easy, and it adds a lot of it's actually really hard to be nuanced in those kinds of things. Even in our courses, it's hard when you're talking one-to-one or one to a group of people. But that would, for me, for the community, and then maybe from the other perspective for people who are using it, try to think about those things. Make sure you understand the patterns, and then that you understand the properties of the patterns, and that you start from those principles and not from purely blindly following the patterns.
I think that's some excellent advice to our viewers / listeners. So I want to leave you with the final question. The podcast is called Satisfying Software. So when you look at software, when do you feel like the satisfaction that, this is great?
I'm first going to say that when we're thinking about satisfying software, I think the first thing we should think about is it shouldn't purely be from a developer's perspective. Business, user, the whole cycle if they all think software is satisfactory, then you have satisfying software. And so that is my main point. Now, if you're asking it to Thomas, the developer, then yeah, it's always satisfying when you've built a model and you now have to add new things or refactor it, and it just works the way you had it in your mind. Like if your mental model is the same as the model in code, that's always satisfactory.
Yeah, it is. All right. Thank you very much for coming on the podcast. And thank you, everyone, for listening/viewing. And we'll see you all later.
Thank you for having me.
You're welcome.
Bye-bye.